Welcome back. We're going to finish up the parallelograms and the properties in this second video and do some example problems. There's two properties we have to go over. And here's the first one. So if you know you have a parallelogram, then the diagonals bisect each other. So in other words, the bisectors are going to cut each other into two equal parts. And there's a diagram for you. Again, I'm not saying the diagonals are congruent to each other. The diagonals bisect each other. Big difference. So here's an example. I have a parallelogram KLMN. I want to know what the lengths of KM and LN are. So we know that LP congruent to PN. So I have X equals y plus 2. I know that y plus 10 is going to be equal to 2x minus 8. So we have two equations with two unknowns. Going back to Algebra 1, you can use your system of equations to solve either by elimination, substitution, or by graphing. Here, I'm going to do substitution. So I'm going to take the y plus 2 and sub it in for the x. So I'm going to have y plus 10 equals 2 parentheses y plus 2 minus 8. So I have y plus 10 equals 2y plus 4 minus 8. So I have y plus 10 equals 2y minus 4. I'm going to add 4 to both sides and subtract y from both sides and get 14 equals y. So I have 14 equals y. I'm going to now substitute it in. So x equals 14 plus 2. So x equals 16. So I solved for my two variables by using systems of equations with substitution. So I want Km. K to M. So now we have to plug it in. So y is 14. So we have 14 K to M is equal to 14 plus 10 plus 2 times 16 minus 8. Again, K to M is the whole segment, so I'm doing segment addition. So we have 24 plus 32 minus 8. So we have 24 plus 32 minus 8 gives us 48 is equal to the Km. This does not mean Ln is 48. If we want Ln, Ln segment is going to equal x. We know x is 16 plus y, which is 14, plus 2. So we have 32 equals Ln. And there are the two answers that we want. So solve for the two variables, substitute back in, and evaluate. Here's one problem. Again. So you have a parallelogram. They want PR, the length of the diagonal, and SQ, which is a diagonal. You know diagonals bisect each other, so you're going to have two congruent parts. So you have 3y minus 7 equals 2x. And you know that x plus 1 and y. So you have x plus 1 equals y. I'm already in y form. So again, two equations, two unknowns. So you're going to use substitution or elimination. Here I'm going to do substitution. So here I'm going to take the and plug it in for y. So we have 3 x plus 1 minus 7 equals 2x. 3x plus 3 minus 7 equals 2x. So I'm going to have minus 2x, add 7 and subtract 3. So we have x equals adding 7, and then minus 3, which is 4. X equals 4. So that means y equals 5, because we know x is now 4. 4 plus 1 equals y, which equals 5. And we can substitute in. So SQ equals x. X is 4 plus 1 plus y, which is 5, which equals 10. And then we know that PR is equal to 3 parentheses ry is 5 minus 7 plus 2, 4. So we have 15 minus 7 plus 8. So we have 15 minus 7 plus 8 gives us 16. Last property, if you have congruent segments and 3 or more parallel lines, that makes the opposite sides congruent to each other. So again, you have 3 or more parallel lines. You know that the transversal is going to be congruent on the same side between the parallel lines. That means the opposite or the other transversal is also going to have congruent segments. So here we go. So in the figure they give you parallel lines, 3 or more, and they say, okay, AB, so AB is congruent to BC, congruent to CD, and this is all 2. Okay, that means the other side of the transversal, is also going to have congruent segments. They're not congruent to each other, meaning EF is not 2, it's 2.25, 2.25, 2.25. And you have to read the question E to H using segment addition. It's E to H equals 3 times 2.25, which equals 6.75. One last example. 3 or more parallel lines indicated by the red arrows. They tell us EF, FG, GH are congruent. That makes the other transversal segments congruent. We know that A to D, the whole thing, is 15, but you know these are all congruent, so we'll call it X. So we have 3x has to equal 15. Or more precisely, x plus x plus x equals 15, which gives us that. 3x equals 15, and we know that x equals to 5. So C to D is equal to 5. If you have any questions on these last 2 properties, again, see me before school, after school, during lunch, or shoot me an email.